Welcome to Homework Lib.
Here we're given the following question in which the values for the mass, for the molecular mass, and the heat capacities and delta H of fusion for a certain compound are given to us. We're told that this substance is going to be heated from minus 23.1 degrees Celsius to 51.8 degrees Celsius. So in this case, the heat that is going to be absorbed is going to be comprised of three different parts. The first one is heating the solid, then melting the solid, and finally heating the liquid. So these three sections, I'm going to put each one of them with a different color in our equation. Blue and purple are going to have different values. As you can see, the heat capacities are given in terms of grams, so we can directly employ the mass. So the first portion of our heat equation is going to be mass times the heat capacity of the solid times delta T for the solid. Next up, the second part is going to be the melting of the solid, which, because of the units that we have here, is going to be equal to amount of mole times delta H of fusion. And the final section over here is going to be the heating of the liquid, which corresponds to mass, heat capacity of the liquid, times delta T for the liquid. So we're given that the freezing temperature is equal to 17.6 degrees Celsius. So that means that delta T of the solid is going to be going from final temperature, 17.6 degrees Celsius, minus 23.1, which is, well, minus 23.1 degrees Celsius, which is going to be the initial temperature. In this case, it's 17.6 plus 23.1, 40.7. So delta T for the solid will be equal to 40.7 degrees. Delta T for the liquid, the final temperature is going to be 51.8 degrees Celsius minus the initial temperature, which in this case was 17.6, because that is the melting point. It's going to give us a delta T for the liquid of 34.2 degrees Celsius. Finally, we can get the amount of mole as the mass divided by the molecular weight. So we can do that operation directly, or we can just replace the value in our heat equation. So the full result for Q is going to be equal to, replacing the values, the mass, 405.3 grams, times heat capacity of the solid, which is 2.96 joules per gram degree Celsius, times delta T for the solid, 40.7 degrees Celsius, plus the amount of mole, which is mass, 405.3 grams, divided by the molecular weight, which is 92.41 grams per mole, times delta H of fusion, which is 8.04 kilojoules, or just to get the result directly in joules, let's put it as 8,040 joules per mole. And I'm going to put down below here the last contribution, which is heating up the liquid, 405.3 grams of liquid after we have heated it up, times the heat capacity of the liquid, which is 1.75 joules per gram degree Celsius. And finally, the delta T for the liquid, which corresponds to 34.2 degrees Celsius. So as you can see, the units of the heat are going to be that of joule. Grams cancel with grams, degrees Celsius with degrees Celsius. Grams cancels with grams, mole to the minus 1 and mole over here cancels out. Over here, grams with grams, and degrees Celsius with degrees Celsius. So the value for Q that is going to be absorbed by the substance when we heat it up is equal to 108,347 joules, which corresponds in kilojoules to 108.347 kilojoules of energy absorbed. So this would be your final answer. With that, it would be all. Thank you very much and have a good one.